symmetric 1D box with infinite height. So suppose there is symmetric 1D box here. Limit is x equal to minus a to x equal to plus a, and potential is extended to infinity. Okay, means the walls are going to infinity height. So you can clearly see here it can be defined in three regions: first, second, and third. So symmetric potential, what does it mean? It means we have symmetric potential. Even potential v equal to minus x will be equal to plus x, means minus sign will be converted to, very simple, you know this all, even potential. So when vx equal to 0 inside the box minus a to plus a, and when mod of x is greater than a, that is at the walls, is potential is infinite. And how we will solve it? Means x is greater than a and minus x is less than minus a. So we can define the Schrodinger equation in first, second, and third reason. In first and third reason, clearly potential is zero. Potential is infinite. So wave function will be 0. Now in second reason, d2 psi x upon dx square 2m upon x square psi second equal to 0. So d2 psi second dx square plus k square psi second equal to 0. So psi second will be, psi second means the wave function in the second region, the box will be a sin kx for b cross kx. We know this. Now when we apply boundary condition and solve this as usual we do it. So psi x in for even function will be under 1 by a cos n pi by 2a x, and for the odd ends, and for so it will be termed as psi even, and psi odd will be, means the wave function for odd function will be 1 by under a sin n pi by 2a x n equal to 2, 4, 6, 8. Similarly, the energy will be n square pi square upon 8m square. So it's very simple, it doesn't ask in exam. Just remember this as we have solved the questions earlier. Okay, same way. So now we will move forward. Now we'll discuss about hydrogen atom. So Bohr's gave atomic theory in 1930. There were three postulates: stationary orbit, and quantization of angular momentum, and energy transitions. Means electron when go through one energy level to another energy level, it will emit certain radiations. Okay, so when you solve this, what will get? This Rm n square h square epsilon naught upon pi m e square, n square upon pi m e square, and n is 1 to 3. So the basic Rn equal to n square r1, and r1 is 0.529 angstrom, which is we call ground state radius, and en equal to minus e square upon 8 pi epsilon naught Rn minus m square upon 8 epsilon naught square n h square n square, and en equal to e1 by n square, and e1 will be defined as m e cube raised to power 4 upon epsilon naught 8 epsilon naught square h square, and this code ionization potential for hydrogen ground state atom minus 13.6 electron volt. Now we will discuss about hydrogen spectrum. So 1 upon lambda equal to E1 by Hc, 1 upon n1 square minus 1 upon n2 square, and it can be defined as Rydberg constant, that is infinite. The value of Rydberg constant in electron volt will be minus 13.6 electron volt, and in meter it is termed as 1.097 10 per centimeter inverse. It can be written in centimeters 10 to the power 5 centimeter, 10 to the power 5 centimeter. So we will discuss about the spectrum. So first we discuss about Lyman spectrum. For Lyman, n1 is equal to 1 and n2 equal to 2, 3, 4. Very simple. Okay. So when n1 equal to 1, we solve the formula. This put 1 upon 1 square minus 1 by 4. So it will be 3 by 4 r. Similarly 8 by 9 r and 15 by 16 r. And when we goes to infinity, means 1 upon n2 equal to infinity. So 1 by infinity equal to 0. So it will be R, which is 13.6 electron volt. This is called the series limit for Lyman series, which is equal to Rydberg constant R, and electron volt, it is 13.6 electron volt. So what is happening here? It is decreasing 3 by 4, 8 by 9, and 15 by 16. So how can we define it? Suppose this is n equal to 1, this is n equal to 2 level, and suppose this is n equal to 0. So for Lyman, what will happen? N equal to 2 to 1, and for a second series for Lyman 3 to 1, 4 to 1, similarly 5 to 1. So when we go to infinite will go like bend. Why will go like bend like structure? Because of when you go upwards, the energy levels are even by 4, even by 9, even by 16. So what you can see here, that the value is decreasing here by 4, by 9, by 16. So the energy gap between those successive levels is continuously decreasing. So at last we'll getting like continuous structure, okay, continuous levels. So for this continuous level we'll get bend like structure, okay. So this is L1, L2 and L3 and so on, and limit is R for Lyman, and Lyman region comes in ultraviolet region. Now Balmer series, for Balmer series, n1 equal to 2 and n2 equal to 2, 3, 4, 5, 7. So when we solve it, 1 upon lambda equal to r infinite, 1 upon n1 square, n1 is 2, and 1 by 9, 5 by 35, r by 36, 3 r by 16. Similarly for we go to infinite, so limit n2 equal to infinite, so we'll go r by 4, which is 13.6 by 4, that is 3.4 electron volt. So for here it will not come to here, n equal to 2, and from every other energy level it will get back to n equal to 2. So we'll get b1, b2, b3 similarly, okay. And same here, 13.6 by 4, okay. And Bama says is in visible region. Now Paschen says, for Paschen says n1 equal to 3 and n2 equal to 4, 5, 6, 7. So first is 7 by 1 by 4, 4, 4, 7 upon 144 r, and infinite is r by 9. So question, how they will ask question? So they will give you n value for one series like Lyman, and n values for same for Balmer series, and they can ask successive difference between these two energy levels for a specific n. So this type of questions are given in the book, and you can solve that question. This type of question will be asked, okay. These are very simple. And he will not going to ask this. He will going to ask you the difference between Lyman and Bauman. So just prepare those questions, very easy, but you have to do it once, then only you can solve that. And if you without solving, if you go on exam and think that I can solve, it is not possible, okay. So hope you will got that. So quantum mechanical treatment for hydrogen atom. So we know that k q1 q2 by r. So k is this, q1 q2 is same, e square by r. And we know that for hydrogen atom we consider as spherical symmetric potential, means from center if we go to same distance we are getting the same potential. So we will apply time independent Schrodinger equation for hydrogen atom. This is time independent Schrodinger equation, and in other form it can be written as h d2 upon d square plus 2m e upon h square psi of r, v of r, psi of r equal to 0. Now here del square should be defined as spherical polar term. So 1 upon r square del by del r square del by del r plus 1 upon r square sin theta del by del theta sin theta del by del theta plus 1 upon r square sin square theta del 2 phi upon del phi square. So here put this, and from variable separation method the wave function can be written as r and y form. So r is radial part and yml is spherical harmonic, we call it spherical harmonics. Similarly, n is principal quantum number, l is orbital quantum number. Now question arises from where in quantum mechanics the concept of quantum numbers arises. So the answer is quantum numbers have natural origin in quantum mechanics when we are solving the differential equation, especially in quantum we use Schrodinger equation. So when we solve any differential equation we need certain boundary condition or some conditions, some restrictions. So when we apply those restrictions on the mathematical equations, here we are getting quantum numbers. So these are restrictions basically, okay, to solve the Schrodinger equations, which is basically differential mathematical equation. Now principal quantum number is n equal to 1 to 3, and orbital quantum number is l, which is 0 to n minus 1, and ml equal to minus l2 plus l. Now for n equal to 1, what is l? L equal to, for 0 s, for 1 equal to p, and then 2 equal to d, and for f, and similarly goes on. So for k shell n equal to 1, l shell n equal to, m shell n equal to, okay, and for n equal to 4, okay. Basically k l m are sufficient. So k equal to, k shell n equal to 1, For n equal to 1, what can be the values of L? L equal to 0 to n minus 1, so only 0. 1 minus 1 equal to 0 possible, so only 1 is possible. For n equal to 2, how many values of L possible? 2 minus 1 means 1, 0 and 1 are possible. And for 3, 0, 1 and 2 are possible. Okay, so 0 S, 1 P and 2 T. Now especially for hydrogen atom, for 1s n is equal to 1, and for s L equal to 0. And if L equal to 0, ml equal to minus L2 plus L, ml equal to L plus 1 number है ना, minus L2 plus L, so s equal to 0, so ml equal to also 0. Now the value of r, theta and phi, so r is 2 by a naught raised to the power 3 by 2 e raised to the power minus r by a naught equal to bore radius. Okay, theta is 1 upon root 2, phi is 1 upon root 2 pi. Okay, and the ground state wave function psi 100 for 1s will be a naught by 1 upon naught pi a naught cube e raised to the power minus r upon r naught या a naught. Okay, now orbital angular momentum for electron, L is under root L plus 1 h cross, and L square equal to L plus 1 h cross square. Okay, now we know the probability of finding the electron around the nucleus is psi square, which is r n L square, and y L m square theta phi. So it can be written as separate part of for radial and spherical harmonic part. Okay, and spherical harmonic can also be separated in form of theta and phi. Phi is azimuthal angle. So psi from variable Sharpless method, psi r theta phi, and p r theta phi t means probability of finding that particle is not depending on the time t. Okay, here not depending on time t, so its probability is time independent. Probability will not change with respect to time. So psi n lm ml is, we call it stationary orbit because of its nature of time independency. Now azimuthal angle is 1 upon root 2 pi e raised to the power iota ml phi. So when we square it for probability density, we are getting 1 upon 2 pi, which is basically the constant. So we are discussing this whole situation. So we can written as the probability of finding the electron of a particle azimuthal angle phi is a constant that does not depend on azimuthal angle phi, and all the electrons probability densities are symmetrical around z axis regardless of the quantum states. No matter what is the quantum states and on which time we are measuring the probability density, it is symmetric around the z axis. Okay, it will not change. Now this should be remember you, means you should remember this. These things will not remember you, but you should remember these things to solve the questions. So the expectation value of r equal to a naught by 2 3n square minus l plus 1. Very important. A naught by 2 3n square minus l plus 1. The expectation value of r square equal to a naught square n square by 2 5n square plus 1 minus 3 l plus 1. Got it? एक बार में याद नहीं होगा, बार बार करना पड़ेगा. You cannot remember this all in a single shot. It's a test match. Each day you have to play well to win the game. One day can ruin your entire career. So the expression value of 1 by r equal to 1 upon n square a naught, and 1 upon r square equal to 1 upon n cube a naught square l plus 1 by 2. Capture this in your mind. Photographic memory must be utilized here. Once again, r is a naught by 2 3n square minus l plus 1. Expression of loop r square equal to a naught square n square by 2 5n square plus 1 minus 3 l plus 1. 1 by r equal to 1 upon n square a naught, 1 upon r square equal to 1 upon n cube a naught square l plus 1 by 2. For ground state, r equal to this is very common, every student know this. R is 3 by 2 a naught and 1 by equal to a naught. From where we are getting this, we are going to solve in our further slides. So a naught, what we call a naught is most probable radius. For ground state probability is psi 100 square, and how will calculate? We will differentiate and will make that differentiation equal to 0, and from there we will getting the point where probability is equal to most probable probability is getting to most probable radius which will give us the most probable states of that electron. Now probabilities and probability density can be defined as square of the wave function. So how will Suppose this is density means probability per unit volume, so probability can be defined as dv times of this, and dv is r square center divided by d phi. So probability of finding the electron inside spherical shell from r to r plus dr, what will be this? This will be this, and from variable separation r theta theta phi phi r square center divided d phi. So r square rnl theta theta phi phi. And for spherical shell, okay, just remember for spherical shell, r to r plus dr, theta is 0 to phi and phi is 0 to 2 phi. Theta and phi are normalized wave functions, so normalized functions, so it will give you the value 1. So we are left with probability density equal to PRDR equal to r square radial part square equal to r. So for spherical shell, especially for spherical shell, probability only depends on the radial part, not depending on the theta and phi part. Why it is so? Because it is giving the constant. Now find most probable radius for 1s. So for 1s, what is the wave function? 2 upon a naught cube 3 by 2 for 1s. Okay, this we just have discussed for 1s. For 1s, 1 upon pi dot pi cube e raised to minus r upon a naught. So when you square it, 2 upon a naught cube e raised to minus 2r upon a naught. So when you square it, you are getting this, and differential with respect to r, when make them equal to 0, so r equal to a naught. So at the bore radius, we are getting the most probable state. Got it? And we can draw the graph like this. For 1s, probability is getting to 0, and if radial part is this, okay, e raised to minus r upon r naught, and whole probability, there are two parts, r square and e raised to minus 2r upon a naught. This is r square and this for whole probability part, okay. And in RNL part, only this e raised to power minus 2r upon a naught. So this is e minus 2r upon a naught only for radial part, and for probability r square and RNL both, and RNL is minus 2r upon a naught. So for increase, for low value, it will probability will increase, and then it will increase. Now which part is dominating? You can clearly see from the graph, the left hand side part is dominating, and average value of this is 3 by 2 a naught. So you can clearly see it is not symmetric, and most probable state is a naught, average of the this part. Now expression value of most probability is r psi equal to psi psi, and r can be defined as psi star r cap psi dv, psi star psi dv, and this is normalization, so the denominator part will be 1, and 1 0 0 is 1 upon pi under a cube e raised to minus r upon r naught. So expression value of r will be r, okay, this r psi square dv, psi square 1 upon pi cube minus 2 r square 985, sin theta and d phi will be equal to d pi, and sin theta will be 2, so this will be this, and pi will be cancelled out, this will be there. Are you getting my point or not? Hope you are getting it. Okay, okay. So square of this is here, and this is the formula of integration h 0 to infinite x raised to power m e raised to minus alpha x dx equal to gamma m divided by alpha raised to power m plus 1. So here gamma m divided by alpha is this part, raised to power m plus 1, 3 plus 1 4. This, when you solve it, you are getting 3 by 2. And not similarly for 1s, this will be there 1 upon r and psi square, which is 1 upon pi cube e minus 2 r a naught, and dv is r square sin theta d theta d phi. So I square this, and d dash 2 and d phi is 2 pi, and dr will be for this. Similarly, same formula here we are having only r1, so gamma 1 divided by alpha raised to power m plus 1, which is basically alpha raised to power 2. Alpha is this part, just do it, and you are getting for 1 by r, 1s is 1 a0. So most probable radius for 1s is a0, as we got it this. Okay, for 1s is a0, for 2s is 6 a0, for 2p is 4 a0, and for 3d is 9 a0. 1649. Okay, 1649, 1s, 2s, 2p, and 3d. It can directly be asked in the examination. 1s, 2s, 2p, and 3d. For 1s it's a0, for 2s is 6 a0, for 2p is 4 a0, and for 3d is 9 a0. Now what is the selection rule? Delta principal quantum number can be anything, but for orbital quantum number is plus minus 1, and since delta is plus minus 1, so m will be minus L2 plus L, so plus minus 1 to 0 is will be answer. Now since suppose our wave function is d and degenerated, so what will be the value of degeneracy? 2l plus 1, L equal to 0 to minus 1. If spin is not included, then it will be equal to n square, and if included spin, then it will be 2n square degeneracy in the wave function. Now orbital angular momentum Lx, Ly, Lz for hydrogen atom. So Lx is minus iota h gas, Ly is iota h cross, and Lz is minus iota h cross. What will be this? Lz is very simple, minus h cross del by del phi. Lx is no, what is L r cross p? R cross p, p is minus h cross del. When you solve it, you are getting minus iota h cross y del by del z minus j del by. Similarly this and similarly this. In spherical quantum, iota h cross sin phi del upon del theta plus cot theta cos phi del phi, iota h cross minus cos phi del by del theta plus cot theta sin phi del by del phi, minus iota h cross del by del phi. Similarly, L cap square, it can directly be asked in examination. Remember these 4 options, it will be hard to take. L cap square equal to minus h square 1 upon sin theta del by del theta sin theta del by del theta sin theta del by del theta del by del theta 1 upon sin square theta del 2 upon del phi square. Very easy. Now when potential is spherical symmetric, so it will commute, angular momentum will commute with Hamiltonian, and any quantity which is commuting with Hamiltonian or energy can be termed as constant of motion. Remember this, if any quantity is commuting with energy operator Hamiltonian, then we'll quote that quantity as constant of motion. So for hydrogen atom, angular momentum is constant of motion. L cap square Lz equal to also 0, L square L cap y is equal to also 0, and L square Lx will also be 0. So this or L square Ly and Lx Ly z means Hamiltonian, L square and Lz all are compatible observable quantities, means they are simultaneously measurable quantities, means they are mutually commuting to each other, which is L square h cap commuting. And how we will commute? So LH plus LHL both are 0, so whole will be 0. Similarly H L square Lx, H L square Ly also compatible observable quantities. So these are having common set of eigenstates. Now eigenfunction and eigenvalues. Lz phi equal to minus so Lz equal to ml h cross, and phi can be defined as azimuth angle 1 upon 2 pi iota ml phi, and ml is minus L2 plus L, and ml is 0 to, so L square will be L plus 1 L square. So here spherical harmonics are eigenfunction of L square. Okay, so spherical harmonics are eigenfunction of L square, and similarly these are also eigenfunctions for Hamiltonian and for Lz also. Why it is so? Because these are also commuting. y0 0 1 upon under 4 pi, y0 1 under 3 by 4 pi cos theta, y2 0 lm L is 2, m is 0, L is 1, m is 0. So both are 0, very easy, 1 upon root 4 pi. If L is 1, M is 0, under root 3 by 4 pi cos theta. If L is 2, M is 0, under root 5 on 16 by 3 cos square theta minus 1. You have to revise it daily to remember these things. It's not easy to remember this all, but you have to. Now, LZ can be defined as this. So x cap LZ, what will be x cap LZ? X cap LZ will be x cap LZ is x py minus y px. X py minus y px. So x cap py minus x cap y px. X cap py, py will become out x cap sorry, x cap this side x py. Similarly xy px out and xy px out. X cap y px out, then y cap out, x will be converted with px. So x px will be iota h cos xy0, x cap lz will be minus iota h cos y. This should be also remembered. X cap lz will be minus iota h cos y. Y lz will be iota h cos x. Z lz will be 0. Px lz minus iota h cos py. Py lz will be equal to iota h cos px, and pz lz will be equal to 0. Now we'll discuss about Stern-Gerlach experiment. So here are silver atoms and gun. This is on and this is screen. So we are getting here two separate lines, two separate patterns. And why it is happening, there is certain explanation regarding it. I don't have time to explain all this because we are fixing the examination part, not interview part. So it is what it is. Let me explain you a few things. The silver, copper and gold. Silver, copper and gold are said to be coin element, and for coin element the 3D structure is fully filled. So sum of angular momentum because of this paired electron will be 0 because no electron is left for motion. But for 4s1 electron, L should not be 0. So there should be only one peak should be observed, one pattern should be observed. But here we are having two patterns. Why it is happening? So from this point of view, now we have to consider the electron are not only having what not orbital angular momentum, but they are having one secret angular momentum also. And Uhlenbeck and Goldsmith term that secret angular momentum as spin angular momentum, which has orbital angular momentum like half integer. Okay, so s equal to half h cos s h s cap z, and s cap equal to ms h cos, ms equal to minus s2 plus s, ms equal to minus r2 plus s. Similarly, you know this all. Yeah, sometimes it feels like shit, but you have to bear this all because there is no other option. Okay, like it or not. Look, if you go in deep and study the explanation, it is very interesting. Okay, but for examination point of view, you have to remember all these things. Like we have discussed, what is the value of r, what is the value of 1 by r, what are the certain states. So all these things should be in your mind, like fitted in the computer memory. Then only you will be able to solve the questions. This is the problem. Okay, you have to do it step by step, 1 day, 2 day, 3 day, 4 day, 5 day, 30 day, so like this. Now spin angular momentum will follow same mathematical algebra as followed by the orbital momentum. What if we are saying is L cap, Lx cap, Ly cap equal to iota h cos Lz cap. Similarly, Sx, Sy, Sy, Hz, Hz, Sx, and all S square will come out with Sx, Sy, Hz. And VL and Vs will be GL minus EL by 2m, and for S minus GS, ES upon 2m. Now, Spinner's and Pauli matrices. For S equal to half, we are having Sx, Sy, and Sz. Sigma is 0, 1, 1, 0, 0 minus iota, 0. You have to remember this also. 0, 1, 1, 0, 0 minus iota, 0, and 1 0 0 minus 1, 0 1 1 0, 0 minus iota, iota 0, 1 0 0 minus 1. It is very easy. 0 1 1 0. Similarly put is here minus iota. Okay, and reverse it this and put minus 1. Now for s equal to half, we are having sx, sy, and hz same plus minus h goes by 2. You have to remember the eigenstate also. What is the eigenstate? For this sx, 1 upon 2 1 1, 1 upon 2 1 minus 1. Very easy. For this 1 upon 2 1 iota, 1 upon 2 1 minus iota. For this 1 0 0 1. Getting my point? Hope you got it. If you don't got it, go to hell. Now sx minus lambda equal to 0, lambda equal to plus minus h goes by 2. Now trace of this Pauli matrices is 0, determinant is minus 1, Pauli matrices are Hermitian, Pauli matrices are unitary, sigma x sigma equal to 2 iota sigma z, sigma y sigma z equal to 2 iota sigma x, sigma zx equal to 2 iota sigma y. Pauli matrices are complex 1 0 1 1 0 0 minus iota iota 0 1 0 0 minus 1. Okay, unitary and anti-commuting, they are not commuting, and determinant is equal to minus 1, 2 iota, and sigma dot sigma equal to 3, sigma s square sigma sigma t square equal to identity matrix is to 2 iota alpha sigma iota I cos alpha and I eta sigma k sin alpha. Remember this. Now data identity for Pauli matrices is sigma dot a, sigma dot b, a dot bi, a dot bi plus iota sigma a cross b. Now for spin 1 spin equal to 1, jx, jy, and jz. Jx is 0 1 1 0. Okay, pay attention. 0 1 1 0. Pay attention here. 0 minus iota iota 0. Here 0 minus iota iota 0. Then again and 1 0 0 0 1 0 0 0 minus 1. For this eigenvectors will be 1 0 0 1 0 0 0 1, and eigenvalues will be h cross 0 minus h cross. Now what is the projection operator? P equal to P, P cap square equal to P cap. So thank you for today. See you tomorrow. Bye bye.